Hi everyone, this is a math guru. In this video, I'm going to show you how to find the angle between the line EA and the plane ABCD using trigonometric ratios and Pythagoras Theorem. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. To find the angle between the line EA and the plane ABCD, the first step is to use the plane and then construct a line AC as shown. That's the diagonal of the rectangle below. And if I draw that out, I have a right angle at B. I have A, the distance between A and B, that's 1.5 meters, as given in the question. Then I have the distance CB, that's 5 meters. So I'm going to find the distance AC, which is unknown. Using Pythagoras Theorem, I have AC squared equals AB squared plus CB squared. That's Pythag. Therefore, AC squared, which is the missing value, equals AB squared, that's 1.5 meters squared, plus CB squared, that's 5 squared. And that's going to give us 2.25 plus 5 squared, that's 25. Therefore, AC squared equals 2.25 plus 25, that's 27.25. And in order to find AC, I'm going to find the square root of both sides. Therefore, the distance AC equals 5.22 in meters. So therefore, I'm going to put that back in. That's going to be 5.22. Now, if I go back to the diagram, because ABCD is the plane, therefore I'm going to use the right angle triangle ACE as shown. If I draw a rough sketch of that here, I'm going to have my right angle, that's 90 degrees at C. I have my E, the distance between C and E, that's 1 meters. I was able to find the distance between C and A, or AC, that's 5.22 meters. The question says, find the angle between the line EA and the plane. So therefore, I have my missing angle. I'm going to call that theta. Therefore, if I label the sides of my right angle triangle, the side facing the angle, that's my opposite. The longest side, or the side facing my right angle, will be my hypotenuse. And the last side, that's my adjacent. So I have my SOHCAHTOA, that's the acronym to remember the trig ratios, TOA. And if you look at what I have, if I'm to find the angle, theta as shown, I have my opposite and adjacent given. And if I go back, the trig ratio that uses opposite and adjacent is my tangent. So therefore, tan of theta equals opposite over adjacent. Tan of theta in this case equals, the opposite is 1 meter, divided by adjacent 5.22. Therefore, theta will be arctan, that's the second function of your tan button on your calculator, 5.22. Therefore, theta, which is the angle between the EA and the plane, will be 10.84 degrees to 2 decimal places. Let's look at the next example for better understanding. For the same question, I'm to find the angle between the line EA and the plane ABCD. Note that if I draw a perpendicular line from E to the plane as shown, and if I draw a diagonal from A to C, then because it's a perpendicular line, I'm going to have my angle 90 as shown. But in order to find the distance, I'm going to call that the middle. Let me call that O. In order to find AO, that's the distance here, I need to find the total distance or the diagonal AC. And because I know that the plane is a square because the dimensions are the same, that's 8 centimeters, then the rule says the diagonals bisect each other. So I just need to find the total distance AC and then divide that by 2. So starting with the distance AC, if I draw out that shape at the bottom, I have the distance AB and C. I have that as 8 centimeters and 8 centimeters. Using my Pythagoras theorem again, to find AC, I have AC squared equals AB squared plus BC squared. That's my Pythagoras theorem. AC squared will be equal to 8 squared plus 8 squared, which is 64 plus 64. So therefore, AC squared equals, if I add 64 and 64, that's 128. And therefore, to find AC, I'm going to find the square root of both sides. Therefore, the distance AC will be square root of 128. That's 11.31 centimeters to 2 decimal places. Therefore, from here, the distance AO is equal to half of AC. That's the property of a square. So AO will be half of AC from the previous calculation is 11.31 centimeters. So therefore, the distance AO will be half of that is 5.66 centimeters. So if I draw the new shape, I'm going to use the triangle EAO as shown. That is a right angle triangle because I drew EO perpendicular to the plane. So I have that. I have my O, I have my A, and I have my E. I'm looking for the angle of EA to the plane. I call that theta. AO I calculated as 5.66. And then I have AE giving us 13 centimeters. Therefore, still using my SOHCAHTOA to determine the trig ratio to use, the question is, what do I have? I start by labeling the sides of my triangle. A right angle triangle, the side facing my angle is my opposite. The longest side is my hypotenuse, and the third side is my adjacent. So the trig ratio that uses hypotenuse and adjacent is my cosine. So therefore, my cos theta equals my adjacent over my hypotenuse, which in this case will be my 5.66 divided by hypotenuse, which is 13 centimeters. Therefore, to find my theta, I'm going to move my cos to the other side. It becomes arc cos of 5.66 divided by 13. Therefore, the angle made by EO to the plane ABCD, which is theta, will be equal to 64.2 degrees to 1 decimal place. Thanks for watching. Bye.